In this tutorial, I'm going to talk about anomaly detection using PCA method. In this tutorial, we go through the topics such as brief introduction of the concept and practical example with Python. We learn how to generate synthetic data applying PCA, anomaly detection, evaluation and visualization of the results, and PCA effectiveness. Let's get started. So what is principal component analysis? PCA is a technique to simplify complex data by reducing the number of the features or dimensions. This is very useful when we work with large data sets, so we can decrease the number of the features. It finds new directions or axes in the data called principal components that capture the most important patterns. The first principal component captures the most variation in the data, and each following component captures the next most variation while being independent of the previous ones. We can represent the original data using a few components if they capture enough information, and this reduced version of the data can still describe most of the original structure. And PCA is helpful for visualization, noise reduction, and finding hidden patterns. This technique is very useful in machine learning, especially when we work with feature engineering. Anomaly detection is a process of finding data points that don't fit in with the rest of the data. In PCA-based detection, we first project data into lower dimensions using PCA. In this tutorial, we set the 3 to number of the components and reconstruct the original data from the reduced version and compare the original and the reconstructed data. If a point has a large difference between the original and the reconstructed version, it might be an anomaly. This works well when normal data follows a pattern or structure that PCA can learn. Anomalies are those that don't follow the main structure, so PCA can't reconstruct them well. Now let's start writing a code. Make sure you have these libraries installed. We need an NumPy, Pandas, scikit-learn, and matplotlib. I've already installed these libraries, so I can load them. So next one is to generate synthetic data. In this tutorial, we used a simple randomly generated data just to make it simple, the process. Here we generate 300 samples with 9 features. So we generate normal data with Gaussian distribution and anomalous data with uniform distribution. And we combine normal data and anomalous data into one data set, and we convert it to data frame. So we initialize the ground truth column and we label it as a normal. So here is 0 means the normal, and we add anomal level, which is 1, to last part of the data. Then we can check the data set. Let's run this code. So here is the output. These are the feature data, and the last one is ground truth. First part is the normal data, and last part is anomal data. So you can see the difference here. So we'll have some big differences compared to the normal data. In the last part, I implemented the shuffle just to mix the normal and anomalous samples. Next thing is we apply the PCA. First we scale the data using the standard scaler. So we have to eliminate ground truth column here. Then we initialize PCA with number of 3 with number of the components. Here we set as 3, and we use a fit transform. Then we collect the output to the data frame. Let's run this code, and here is output PCA1, PCA2, and PCA3, and their values. To detect anomalies, we first reconstruct the data from the PCA space using the inverse transform method. Then we calculate the reconstruction error. They are the sum of the squared errors. Then we add the construction error to the data frame and determine anomalies based on the reconstruction error. Here we set 95th percentile as a threshold. That means the top 5% of the errors will be the threshold. Then we add to the data frame. The next is evaluation. We can use the confusion matrix and the classification report to evaluate the results. So first we have to run this code. So okay, now we can run this one. So here is the output. The confusion matrix looks good, and here is the precision, recall, and F1 score. All looks good, and accuracy is 99%. Then we can visualize the result to check the visually. Here we use scatter plot. For normal points we use blue color. For anomal points we use red, and we add the levels. Let's run this one. And here is the output. So blue colors are normal data, and the red one is anomal cases. So we can easily identify the anomal cases. They are located far from the majority of the data. In this test, the PCA worked well, but it may be different. It might be different when we work with real data sets. And if you want to change the anomalies criteria, so you have to implement, for example, implement the this percentile value. You can change the percentile value, so to detect the extreme anomalies, you can increase this number, and also you can increase the number of the components when you start the PCA initialization. So in our case, it worked well. So we detected all the anomalies here, and there is one method in PCA, so it called explained variance ratio. So it defines the total variance captured by the principal components. Let's run the code, and it says explains variance ratio for each PCA. The first component covers 16%, the second one is 13%, and the last one covers 12%. Total variance captured by 3 PCAs is almost 43%, which is lower than expected. Yeah, because it is we selected only the 3 components. So if we increase the number of the components, so we can cover most part of the data. So if you want to know how many components we need, you can also find out this value. So here is the code. For example, if I want to detect, if I want to cover 80% of the data, how many components do I need? Let's run this one. And it says number of the components to retain 80% variance. We need 7 components. But in our case, it worked well with 3 components because it's very easy to see to visualize in a graph. So that's why I selected 3. So we can easily just find out the depths of all the points. That's it for this tutorial. I hope you found it helpful. If you liked this video, please subscribe my channel and hit like button. Thank you for watching, and see you next time.